Remember, it's often like impossible to apply a treatment or a survey or an observation to an entire population of people or things. For example, if I wanted to find out if a medication worked for ADD, I couldn't take every single person in the entire United States who had ADD and give them that medication. But what I could do is I could get a sample of those people and I could give them the medication and conduct an experiment to see if it worked. Same with a survey. If I wanted to find out how much time people spent on their phones, I couldn't ask every single person in the entire United States. So I couldn't ask the whole population, but I could get a sample of people. And now if we pick a good sample, the data we get from the sample is going to match the data of the population. In other words, if I find that people spend an average of 4 hours on their phone in my sample, then if my sample was a good sample, that means that people in the population spend about 4 hours on their phone as well. But what happens when my sample doesn't represent the population? Then there's something called bias. And bias basically means that I picked my sample very poorly, and therefore my sample data does not represent my population. So let's look at an example of that. Let's go to the cell phone example. So I have a statistical question: how many hours a day do people spend on their cell phones? So as a high school teacher, I have a couple options, right? First, I could ask all of my students, and I could do a survey of all of my students, and I could say, how many hours a day do you spend on your phone? Or I could ask all of my colleagues, and I'm in my 30s, mid 30s, and so we're Gen Xers, or Zennials actually, is my generation. So I could ask them, how many hours a day do you spend on your cell phone? Now let's imagine that I did this and I asked all of the high school kids how many hours they spent on their cell phone. Do you think that's a representative sample of the United States? Do you think that data that I got, if I found that they spent 6 hours on their phones, do you think that would be a good number for the whole population? Well, of course not, because the population isn't made up of just high school kids. What if I ask people my age? Well, I would probably get a lower number, say 3 hours. Especially if they were teachers, because we're not on our phones during class, so we're going to get a much smaller number, right? But is that representative of the population? No, of course not, because the entire population is not made up of 35-year-olds. So how would I get a sample that was not biased? You can decide that on our one of our slides. You can decide, what would I need to do? What kind of a sample would I need to take to be able to not have bias in this example? Here's another example. If I wanted to know how happy people were, and I just went out into the park one day, and while everybody was picnicking on a Saturday, and I said, are you happy? And I got that 70% of people said, absolutely, I'm very happy. Do you think that would be a good survey? What about if I went to on the subway, or let's see, in Montana, what do we have that's equivalent to a subway? The commute to work. Or if I ask people Monday morning, the first thing they get into the door on Monday morning, are you happy? Do you think that I'm going to get 70% of people saying they're happy? Probably not. So this is another example of bias. If I ask people in a setting where everybody is kind of naturally happy, of course there's going to be bias in my sample, and it's not going to represent the population as a whole. If I ask people in a setting where people are typically fairly grumpy, I'm also going to not represent the sample or the population as a whole. So this sample might overestimate the happiness level, and this might underestimate the happiness level of the population. But either way, the sample data doesn't match what's actually happening in the population.